Hello everyone, today we'll be working on running your teachable machine model in Kaggle. If you have your project saved, you can open it or you can create a new project. So I already have mine saved to Drive, so I'm going to open it. Okay, so once you have all your images here and your classes, you can train your model. Once we're done training, we'll export the model and bring it to Kaggle. Okay, once your model is trained, we can export it. So click Export Model, click TensorFlow, make sure Keras is enabled here, and you can click Download My Model. Also, you might see a code snippet here, so we'll be using something similar to the OpenCV Keras code snippet, however we'll modify it to make it work in Kaggle. Okay, once that's downloaded, you want to open your converted Keras zip, and this will create a folder called converted Keras with a h5 model and a class names txt in it. Alright, as you can see here, I have a Keras model and I have a labels.txt with two classes. Okay, now let's go to Kaggle. Okay, so if you don't have a Kaggle account already, you want to click register with your email, and enter your email address and password, or a password you want to create, and then enter your display name. After that, it'll send you a verification email, and you want to enter the code from that email onto Kaggle. However, I already have an account, so I will just sign in. Once you sign in, you'll see something like this. So you want to create a new notebook, but I already have one, so I'll go to that. So here we have TM model video example. Okay, as you can see, I have two input data sets here. So to add these, you want to click this upload button, and you want to upload your Keras model and your labels, as well as a test image or multiple test images to test your model with. So once you do that, you can upload here and then enter a dataset name. Okay, now let's work on the code. Okay, so first thing, we need to import Keras. So Keras is a high-level API built on top of TensorFlow. This library just makes things easier to code. And as you can see, we have the Keras model type. So let's import that. Okay, so once we've imported that, we can copy the path of the Keras model. You can click this copy file path button, and then you can define it as a string. Okay, so once we have that, we can load the model with load model, and we can provide the model path. Okay, now that we have that, we can load our class names. So basically, we want to open this file and then save it as a list. So if you open it, you can see that here I have Owen and Priyanshu. So what I can do is I can open it in read-only mode and then save this as a list. Oops, it looks like I made a pretty big mistake there. Okay, so replace that equal sign with a comma. I'm not sure why I didn't see that earlier. Let's run this. Okay, now let's create another code block. Okay, so we want to import three libraries. We want to import IPython to display the images, our testing image, once we run it through the model. We also want to import NumPy to convert the image to an array and perform manipulations and processing on it to provide to the model, as well as OpenCV, CV2, to open the image, read the image, as well as process it. Okay, so we want to select a testing image. Let's just say this image here. As you can see here, this is a testing image I took in MedBio. So we can define the path as a string. Now we can read the image with OpenCV, so we call cv2.imread. Okay, next we want to resize our image to a 224 by 224 pixel image. The reason we do this is because Teachable Machine had their training images as 224 by 224 pixel images as well. So we want to follow that format. Okay, so what we do here is we use cv2.resize, we provide the image, and then we define the pixel size that we want the image to be, which is 224 by 224. And then interpolation is the method by which we resize the image. So in this case, we want to use interarea because it's the most effective for shrinking. as you can see here, but intercubic is best for expanding the image. Okay, after this, we want to convert our image to an array. An array is essentially a list, but with only one type of data, or one data type. And we want every single pixel in this 224 by 224 image to be represented by RGB values, the color. And then afterward, we can normalize the array to provide to the model. Okay, so essentially what we do here is we convert the image to an array. An array is essentially a list of only one data type with every single, in our case, we'll have every single element be a 32-bit number. And then we want each pixel to be represented by an RGB value. So a red, green, and blue value, which is just a color. And each RGB value will range from 0 to 255. So we want to normalize this range to between -1 and 1 for the model. Okay, so essentially what this does is it converts this array and it shrinks it down. So if a RGB value was 255, if it was divided by 127.5, it'll become 2, and 2 minus 1 is 1. However, if the RGB value was 0, 0 divided by 127.5 would be 0, 0 minus 1 is -1. Therefore, the range will be from -1 to 1. Okay, next we want to pass this array to the model to have it predict who is in the image. Okay, so this will return an array of confidence levels for each class. Okay, let's print that out so we can take a look. Okay, as you can see here, there are two values. These represent two confidences. So what we can do is we can find the maximum of the two, which is this first one. And then we can get the index and also get the class name. And then we can reformat this confidence to something that's a bit more readable. Okay, so essentially what this will do is it'll get the maximum of this array. So it'll get the index. So in this case, it'll be 0. So we can look at the class name. So class names will be from this txt. As you can see, 0 is Owen, 1 is Priyanshu. So it should return Owen. And confidence, so this should parse this list and get this array which is inside of it, and then get the index. So it basically gets this 9.9 whatever number. And then now we can print the class and then also print the confidence score and reformat it a little bit. So it's a little bit more readable. Okay, so we have two print statements here. We have class and confidence. So for class, we have class name and then we have some string slicing. The reason we have that string slicing is because in our labels.txt, there's a 0, a number, and then a space, and then the class name. So we want to get rid of these first two. So, but Pythonically, the 0 is the 0th, the space is the 1, and then the O is the 2. So we want to start at the 2 and onward. So for confidence, what we do is we round the confidence. First, we multiply it by 100 to convert it to a percentage, and then we round it, and then we'll print it out. So let's run this. So as you can see, it shows class, Owen, confidence, 100%. Looks like I missed a colon here. And as you can see, there's a new line here. So what we can do is we can use n equals this to make it not a new line. We'll run it, and then we have class Owen, confidence, 100%. So we can also display the test image. So we can use image and then pass the input path. If we run this, as you can see here, we have the class, the confidence, and then the image. Okay, so that's it for today. Our next meeting is on Wednesday, April 26th in Ms. Johnson's room, so we hope to see you there. We'll be going over gradient descent.